Alright, welcome to our third video. We're talking finally about pH. Very common scale, probably heard of it before. Hopefully you remember some of it. So, expressing hydrogen ion concentration and hydroxide ion concentration, as a reminder, H plus and OH minus. And as another reminder, this can also be H3O plus, is boring. Like, I don't want to do that. I don't want to keep writing times 10 to the negative. It gets so frustrating. Now, you may like it, but I'm just saying I'm a math major. I like numbers. I literally paid people money to study numbers, and I don't like writing them. So if you do, go ahead. Probably the first of your kind. Most people don't like doing that. It just takes up an annoying amount of space. So instead, we use the pH scale. It is wonderful. I love this a lot better, especially than the annoying concentrations. pH is basically the negative logarithm of the hydrogen ion concentration. It's the negative log of the hydrogen ion concentration. Now, hopefully you're in Algebra 2. And I'm going to pretend that you're all in Algebra 2, since that's kind of a prerequisite for being in my class. About a third of you I know are not. I'm not really sure how you got in my class, but so be it. If you're in Algebra 2, you've likely learned logs before. You probably don't like them for some reason. I don't know why kids just don't send them. They're really easy, I'm sorry. But if you have issues, come talk to me. If you're in geometry, you probably never heard of them before. Or if you're at a different school, then hopefully you've heard it. If not, well, whatever. I'm going to teach you. They're pretty easy, pretty doable. Again, if you have questions with the math, come talk to me. I'll gladly help. Or if you're watching, send me an email or something. I don't know. So, in equation form, pH equals negative log of hydrogen ion concentration. There is a button on your calculator probably that says LOG. It stands for log. That's it. You take your hydrogen concentration, you take the log of that, and you make a negative. Woo. It's hard. Except not. That's how you find your pH. So, a solution with a pH less than 7 is considered acidic, and a solution with pH greater than 7 is considered basic. Neutral is considered 7. To be honest, somewhere around 7 is typically considered neutral. Like a high 6 or low 8 is acceptable as well. Technically, by definition, though, it goes with 7. So if you have people like, wait, this stuff doesn't taste acidic, if it's around 7, you're fine. But in this class, at least in the chemistry, stick with 7. So for example, polar opposites are hydrochloric acid and sodium hydroxide, really strong bases. But we got lemons, or down here, that's why you don't just want to suck on lemons. They're very acidic, they're very strong, they've got a very low pH. You got vinegars, about a 3. Tomatoes actually are kind of acidic. They're up at 4. Bananas, minorly acidic. Looks like kiwis, I guess. No, potatoes. I think potatoes. Yeah, kiwi, you'd probably see the green center. And water's about 7. Eggs are kind of slimy. They're 8. Baking soda is a base. We got hand soap. We got ammonia. We got bleach. We got oven cleaner stuff. Okay, didn't know they sold that. Okay, so there you go. That's just kind of an idea of how things are. Of what common things you deal with, what their pHs are. Now please, I'll tell you that later, so never mind. A solution with a pH equal to 7 is considered neutral. I don't know why I didn't put this up there, but okay, there you go. 7's neutral. Again, in real life, we think of neutral things. Like our brain is fine with calling something not acidic if it's somewhere around 7. In chemistry, though, we're going with just 7. Just like with last video, we only are neutral if the hydrogen equals the hydroxide concentration. Not if they're just close, they gotta equal. So, to find H plus from your pH, here's the following equation. This is where your Algebra 2 skills hopefully are coming in handy, but if not, well, you'll do fine with them next year. Your hydrogen is 10 to the negative pH. In your calculator, if you have ever asked me questions about your calculator, now's the time to take notes, because you should know how to do this. You're going to be putting 10 to the negative pH. Pretend that's a number. So if our pH was 7, then you would tell me 10 to the negative 7. or sometimes in your calculators you're actually able to put them as exponents. I don't care how you do it, but that's what I'm showing you right there. pH, by the way, mainly used for solutions with low concentrations, like less than 1 molar. I've had a lot of people think otherwise. They're like, dude, that's got a pH of 1. It's going to like burn your face off. No. Normally, if you're dealing with something as pH, it's really not that strong. Even the normal range for pH is 1 to 14. A standard, like, not really even tickle your hand, weak hydrochloric acid is about 1 molar. A concentration, a pH of a 1 molar acid is -1. Okay, nope, sorry, it's 0. Okay, that's not even that strong. Like, I could pour that straight on your hand and you'd be like, yeah, whatever. I mean, I wouldn't. It may react to something, and if it got into like a sore or something, that would hurt. But that's not even that strong, and that's off the chart on pH. So keep stuff with a low concentration off your hands, keep stuff with a high pH off your hand, but keep in mind pH is mainly used for things that basically they're so small that it's getting annoying to write their concentration. Because if I have a 1.0 molar, I'm just going to call it 1 molar. As opposed to a 2.2 times 10 to the negative 14th molar. That's annoying. I prefer to say a pH of like 13. It's a lot easier. Anyways, difference of 1 pH is a difference of 10-fold. Now, apparently a lot of people know that, don't know what the word fold means. It basically means a solution with a pH of 1 is 10 times stronger than a pH of 2. Okay, that means if you're going from a pH of 3 to 2, you're going to basically be 10 times as strong. Or 4 to 2 will be 100 times as strong. 100 times as concentrated, by the way. Keep in mind it's really, really, really still small, but it's still 100 times strong. Or a pH of 5 to 2 would be times 1,000. How we're doing that is basically 3 minus 2 equals 1. This is 10 to the 1. 4 minus 2 is 2. This is 10 squared. 5 minus 2 is 3. 10 cubed. So there you go. That's how pH. That technically means that lemon juice is 10 times as strong as whatever was above it. I'm sorry, I don't remember. But again, they're still weak. It's just stronger. Well, more concentrated, technically, not stronger. Okay, 2 common ways that pH can be determined, though, is through indicators or pH meters. So, I think we talked about pH. Yeah, we talked about indicators before, how acids turn them red and bases turn them blue. That's mainly for litmus paper, which is a type of indicator. There's a couple more types that we're going to talk about, though. Indicators typically have a range of pH values in which they appear as certain colors. They're typically solutions, we'll talk about this soon, but a very common one is called phenolphthalein. And phenolphthalein basically says that up to a pH of about 8, we're going to be pretty much clear or colorless. However, once you start getting a pH above 8, it starts turning red and it's actually kind of a pink. So that lets you know if you put a few drops of phenolphthalein in a solution and it's clear, you're probably going to assume it's either neutral or an acid. But if it's pink, you're probably going to assume it's a base. So if I put in some methyl orange and it gets dark red, I'm going to assume it's a pH of 3 or below. But if it's kind of yellow orangey, it's kind of, a little bit higher. Both of which are an acid, but you can tell whether it's a strong acid or not. So, there you go. Thymol blue, by the way. Red for really strong acids, yellow in between, and blue for really strong bases. So, just kind of depends on what you're doing. Yeah. They're, like I said, commonly solutions, but we can also have what's called litmus paper, which is basically, I think it's paper dipped in solution. I'm not actually sure how that works. Normally, though, there's solutions, like we put a few drops in it. When we talk about titrations, I'll show you more about these. Lastly, though, we can use pH meters. They're a lot more useful. They're a lot more accurate. But both ways are a valid way of getting an idea of pH. Indicators are very useful for quick qualitative measurements, meaning is it an acid or a base, yes or no. And meters are more quantitative, meaning, all right, what is its pH? So instead of saying, well, it's probably less than 7, you can tell me it's like 5.2. Hopefully you see the difference. I gotta stop dropping that. All right. So you now get to figure out what the pH of these are. And then let me know whether it's acidic, basic, or neutral. Keep in mind that pH is based off hydrogen. So if they gave you hydroxide, you do have to first find the hydrogen concentration. So come back in a few minutes and I'll show you what they are. All right. So as with last time, I'm going to start by showing you all the concentrations. We need hydrogen. We don't need hydroxide. So I have hydrogen, I'm good. Hydrogen, I'm good. I have hydroxide, I need hydrogen. I have hydroxide, I need hydrogen. So I'm going to calculate those, show you them, and then I'll show you how to find the pH of them. All right, so here are our hydrogen concentrations. Now we're finding the pH. Again, pH is equal to negative log of H plus, which means that we're going to have the negative log of 1 times 10 to negative 6. And that's going to equal 6. All right, and now I'm going to basically find the pH for the rest of these, and I'll write them over here. These will be our pHs. All right, so we have a pH of 6, 3, 12.4, and 3.5. Lastly, we need to figure out whether it's acidic, basic, or neutral. This is less than 7, so that's acidic. Less than 7, acidic. More than 7, basic. Less than 7, acidic. Now, we didn't have any neutral. Neutral would have happened if we had a pH of 7. But there you go. Find your hydrogen, plug in negative log. You got whether it's acidic, basic, or neutral. There you go. Thanks for watching.